A scuba regulator is a complex piece of equipment designed and engineered to exact specifications. The design phase takes a considerable amount of research and development time. Manufacturers make regulator first stages from brass or titanium. Workers machine each part from a solid rod of metal. Most regulators make extensive use of brass. It is an ideal metal that doesn't oxidize as readily as steel or aluminum and withstands high pressures. The brass rod spins and the tools remain stationary. Various tools precisely machine the metal into a regulator body. Inspection ensures that each part meets exact standards. Titanium's greater hardness requires a different machining process, but the result is the same. A mixture of silicone and water lubricates the machine tools as they carve tank yolks from the metal. To use brass in a regulator, it must be chrome-plated. Moved from bath to bath, caustic and acidic solutions clean impurities from the brass. Electrolysis fuses layers of metal to the brass. The first layer is copper. It serves as the primer. A nickel layer provides corrosion protection. The final step is the chrome. Chrome acts as a sealer, keeps the nickel from oxidizing, and adds some hardness and shine. The high-pressure seat is the heart of the first stage. It seals by placing plastic against metal under pressure. Inspection ensures that the plastic and metal of the high-pressure seat have bonded properly. A worker carefully assembles a diaphragm-type first stage. This design prevents water from entering the mechanism with a diaphragm that balances tank pressure to the ambient pressure. The high-pressure seat assembly combines the seat, filters, and retaining clips in one unit. The addition of high and low pressure plugs and the yoke completes the assembly. Testing verifies that the first stage functions properly, lowering the tank pressure to an intermediate pressure usable by the second stage. Each regulator's second stage gets a serial number. Manufacturers maintain records on each regulator for several years. Every valve, spring, and O-ring in a second stage regulator must function perfectly for the regulator to deliver air to the diver. The regulator body itself is injection molded.
That's why I got him. Son, which ones are next after I finish doing those? So the shiny goes on the bottom, right?
The diaphragm serves as the activator for the regulator's demand valve operation. When the diver inhales, the diaphragm pushes on the operating lever, which opens the valve and releases air for the diver to breathe. The second stage goes through tests to make sure the purge valve works properly and that there are no leaks. A regulator must pass a final check, ensuring that all the parts work together properly. This check is similar to the process used by repair technicians at dive centers after overhauling a regulator. Lastly, the assembled regulator goes out the door.